matches.
Okay, fair enough. Yeah. Okay.
It says I'm live. Right,
Yeah,
welcome to
looks
the
good.
documentation improvement stream. Uh, right, Blaze, so you had a question about where to change what, the prose, right, of the documentation.
Yes, the pros, exactly.
So there is currently in the Python language reference
Uh-huh.
an introduction which says something about alternate implementations like IronPython, which I don't know, I haven't heard in a
Wow.
bunch of years. Ooh,
Yeah.
3.4. That's reasonably current. Just released Python 3.4. Not bad, not bad. Python though I think is stuck at Python 2 still.
Oh, wow. Okay.
Yeah, 2.7. They'll get there. I don't know if there's any new implementation. Well, there's MicroPython for which the reference documentation should be valid. Anyway, that's beside the point. Then there's notation, which is the description of the notation used for exactly the things we're changing. So this one will probably need some rewriting. It says it's a modified Backus-Naur form, which is
Right.
something where
Right.
oh, this is almost what we're familiar with different symbols. So I guess it's modified and non-standard, it probably needs to be described from scratch.
Okay.
I mean, we can probably assume the reader will be familiar with some kind of grammar specification.
Oh, yeah.
This is probably a good enough introduction. But then it here says, what's a vertical bar, what's a star, what's a plus, and so on. And to that we might want to add whatever's in here. So it's cover, this is cover, this is not in there. There's a sequence vertical bar that should be all covered. This one, the gather, the expression separated by a separator. I think we do want to use that, but it's non-standard, so it should appear in there. But these three we're omitting, so those should go there. Now the thing about this notation section is that it's also used for lexical analysis, which uses similar stuff, but with these textual descriptions of characters, for example.
Okay.
Right. So, well, there's basically a comment saying what should be in this place. So there are two forms of the grammar syntax. One is the one we're using. The other one is this one, and I think the only thing that's different are these character ranges and the stuff between brackets.
And is that what people when people say peg? Is that what they're referring to?
So peg is the peg grammar is this one.
Okay.
That's the
Oh, there it is. I see. Okay.
Grammar.
Oh.
That's a type of parser.
There's a, okay. It's a mixture of even if
oh, it's also a syntax thing. Try 0, 1 or more optional and predicates not pretty good. Okay, so they do have these look-aheads in the formal grammar, but they don't need this shorthand, the gather thing, and I guess they don't need cut for some reason. And the formal notation uses slash instead of the pipe, which is, I guess, different from the Bacchus Nor.
Okay. Do you want me to include some description of the differences?
No.
No. Okay.
I would say we're okay saying that it's modified this Bacchus Nor.
Yeah.
I don't know.
Okay.
How that's pronounced.
Yeah, Bacchus Nor. That's.
But you know, the
good.
fact that it's the peg grammar is important for the full grammar specification, I guess. Because that means ordered choice in peg.
Ordered choice.
In
Okay.
traditional grammars, the choices are basically equivalent, so you can have ambiguous grammar if you're not careful. In peg, if the first choice matches, it's always taken, so you can't have anything ambiguous. Yeah, and that's written slash in traditional grammars, but slash is just too weird for normal grammars. But since we're simplifying these, that's a detail I would like to basically leave to the full grammar spec. So maybe there should be a note saying that the syntax in the docs is slightly simplified, and it's meant to give you an idea of what the grammar is, and if you want all the details and the formal grammar, then you should look at this page.
Okay, good. And then we should have a link to that page. I'll put a link in there.
Right.
Okay.
Do we have a link to notation? No, not in lexical analysis. So yeah, nowadays people don't read docs like a book. So
right.
I don't expect them to start with the introduction and see the notation section. So we should probably at least have a note at the start of each chapter. Not that people read the whole page anyway, but at least they can search for it in the browser. And
sure.
Expressions already has some syntax notes, but it would probably be better to link to the introduction and put everything in there. And the same thing should probably, well, this says in this and the following chapters. So we should probably, have a one-line note with the link and repeat it in each chapter.
Okay. And the link would be back to the introduction, which has the description of the modification to the notation thing. Okay, beautiful.
And I think you can send that directly to CPython. It doesn't have to be part of the pull request.
Okay. Is there should I make an issue for it, or is there already an open issue for this stuff?
I don't think there's already an issue. Okay. Well, so that depends on if you want to go through it first. So if you don't want to go fully public at first, then make a pull request to my repo, and whatever process.
Yeah, I think I'd rather.
Will work there. And then.
Sure. Okay, I'll do that. Just because it's my first time, and I
Right. So let's do a review privately and then publish it.
Yeah, I don't mind making a fool of myself, but in this particular context, I think maybe I'd rather not.
Yeah. So I think the major problem there is that too many people will jump on it and do reviews for
Yes.
you, so it kind of wastes people's
Yes.
time.
Yes, exactly.
So it's probably easier to do the mentoring thing and figure stuff in private first, and then do the proper process.
Cool.
Thank you.
Oh, yeah, my pleasure.
And if you don't have any other question, I guess it's time to start with where I left off last time, which is inlining. I want to put the statement plus inside here. So let me get my bearing. This is the code. I have the function generate rule lines, which takes some rule names and yields individual lines to be included in the documentation. And the way this works now is it takes a list of the rule names, so there doesn't need to be so for example, this thing is generated. Let's see this. Let's see the source. So the file snippet is generated purely from this line and the grammar, of course. So everything here is auto-generated, and here I have a specification of what I'm documenting. It doesn't have to be just one rule. If I put file interactive here, then hopefully I need to delete this one too. Everyone can be only at one place. So if I put both file and interactive, I will get those to merge, basically. That's useful. That will be useful in some situations. So let's do that. So the way this works is it simplifies every rule, yields it, and then it scans basically the definition for any more rules that should be documented. So here it scans for the statements, it finds another rule named that. It also scans the end marker, but there's no rule end marker, that's a token, so that's quietly ignored. And the new rules are added to these rule names, right? So this is not a for loop, it's a while loop, and the collection is changing while I'm iterating over it. So this I will have to change that logic entirely, because if I'm doing inlining, then I want to consider all the rules at once, and then maybe I'll get rid of some of them. So here I'm making a copy of the rule names, or maybe making a list if it's a generator. Here this is deduplicating, I don't need that. So what I will do is first collect all the rules in a dict, and then yield them, right? So let's make a dict. What is the scene rule names? I I don't need that since I'll be adding stuff to rules here, so let's remove that. Let me give a better name, well, for example, rule names to add. And while we have some rule names to add, we take the first one. So want to have them in the same order as they're in the docs. And I will do this part, except I will look in the rules that I'm creating now. That will be a dict from name to my nodes. So if this rule name is already there, I do nothing. I get the actual grammar rule, then I convert it to my node class. Then here is some simplification. I probably want to do that at this point. Maybe I want to leave it to another point. And now instead of yielding it, I add it to the rules dictionary. So rules with this rule name is this node. Okay, so all of this yielding is now skipped here, and then I go through all the descendants of the node. Get the rule name in case it's a non-terminal, and if it is in top level rule names, I add it to the rule names to add. Okay, so this is like the data gathering part of this algorithm. And then what I want to do is go through these rules. And do the printing part. Right, and that should hopefully result in the same thing as before. Oh no, because I'm using the pgen here. So I definitely want to use name. And this will work on non-debug, or maybe it'll do something weird for non-debug. Right, so since I'm doing the printing in a separate loop, by here I have forgotten the original grammar rule for each line. So I either need to stash it on my node object, or I can just look it up again. So this is in debug mode. I print out the original rule from the real grammar. Right, and that gives me exactly the same output as before. It's refactoring. I will try to do that for debug. Oh, that's great. So why is my little shell pipeline going in a loop? So if I pass dash dash debug to my script, I should get all the debug output. Everything should work. again as before. So from page N I get this wrapper and the dump as well. So okay, that looks like it's doing exactly the same thing as before. But now I have a dict of rules. Let's print that out. Let's p-print that out. Right, so there's a dict with file and so on, statements and so on. Right, and with that I can start inlining. Let's put it in Git first though. So I don't output the data directly. I have it in a dict. So what do I need to start to inline these statements in here? I guess for every rule that I wasn't specifically asked to document here, I want to count how many times it appears in all the other rules, and if it appears exactly once, then I want to remove it from my dict of rules and instead replace that one occurrence with its contents. Does that make sense?
Yes, it does.
Perfect. So how do I do that? So I first want to check if my name is not in this original list of rule names. What do I call that? Ooh, this is a long script now. Split, yeah. So this comes in as a list. I don't want this as a as an iterable. Okay, so if the name is in these rule names, I want to skip it. Otherwise, I basically do this loop again and look in all my rules. I guess it's like this. So I look in all of the rules, I generate all of the descendants for them, and if that descendant is a non-terminal and its value is the name I'm looking for, then I count it. Right, so I start at 0. I count how many times this name appears in all the descendants. Right, and then if count is 1, then it should be inlined. I didn't get anything. My code didn't work on the first time. Right. Nothing is here. Because I'm generating descendants of that node, which doesn't really refer to itself usually. Right, so now I get statements should be in line, statement new line should be in line, simple statement should be in line, and so on. Right, so statement new line does that. Work here, so statement new line goes in here, simple statements goes in there. Yep, that's exactly what I wanted this to do. Can this be simplified?
Let's see.
Yeah, I definitely can. So what I will do is I can count all the value of non-terminal descendants everywhere.
Mm-hmm.
And right, do I have collections already? So I will basically count the rules, or reference counts. Make a counter. Are you familiar with counter?
No, not yet.
All right. So counter is a dict subclass. Do you know default dict?
Yes.
Right. So counter is basically a default dict with a default 0, and it's used for counting stuff. Right. So if I do now reference counts. Reference counts. Blah, 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 plus equals 1, then this entry becomes 1 basically.
Okay.
Right. So this
it kind of helps
count stuff.
Mitigate off by 1 errors.
Not really. It's basically a default dict with a default 0, but it has some convenient stuff for example, if you have a list of things, then you can put it in here.
Oh.
And it
I see. And it tells you how many things. Okay.
It'll give you a dict of the counts of like individual stuff in there.
Oh, so that is slick.
This is equivalent to then going for item in this list of stuff and adding 1.
Okay. That's cool. Thank you.
Yeah. So whenever I want dict with where the values are counts of something, I always go for counter because it has some convenience stuff.
Nice.
For that. I don't know if I'll need it. Maybe in this case, default dict would be enough. But it's counts, so counter it is. So I go through all the nodes in values. I generate all the descendants, and if I get a descendant that's a non-terminal, then I take its value and add 1 for it. So at the end I should have the counts of all the descendants, right? So there's a counter with del targets. Oh, let's take this one. So here statements is referenced once, and statement is referenced also once. Let's see what that is. Yeah, here. So statements is referenced once, statement once, two.
Very nice.
I get all ones here because I'm using a simple example. But for del targets, which is in simple statements, I guess.
Ooh, okay. Yeah.
So I'm generating that one as well. So del targets here is referenced a bunch of times. Yeah. And I get all those times counted.
Right? Oh. Yeah, I love it. Okay. It's starting to make more sense.
And I probably only want to count the ones that are in my rule names, just to filter out the things I can't inline. Filtering out a little too much. Oh, not in the original rule names, but the rules. Right. Rules. So that's my rules dict. So now I'm getting rid. Right. So here, for the top level components, that's this one. I'm only considering the references where I also want to document that rule in this section, right? So I filter that out. Let's see if I can simplify that a bit. This descendant value is too long, so let's name it. Use the name. Right. And then for I go through everything I had there and I see what should be inlined. Okay, that's looking good. There's one more thing I want to refactor. I don't know if now or eventually, and that's this loop where I generate all descendants and then I do isInstance on each one of them. Maybe I want to add this functionality to generate all descendants. Right, so can't filter. And I will only yield nodes that are subclasses of this filter. Instance. Filters too generic. So I can now generate all descendants that are non-terminal and get rid of this indentation here.
Oh, I see. But that I'm not sure I understand that little trick there after filter object. Is it a pipe?
So yeah, this is a default value. and the base
Mm-hmm.
class of everything in Python. So isInstance of object will always be true.
Oh, okay.
Or I can say I want to filter out nodes, since anything, well, all the nodes are nodes, right?
Oh, I see. No, okay, that makes more sense. Yeah, in the on my screen, and it's just I think an artifact of the resolution. It looked like the closed parentheses look like a pipe.
This one.
Yeah, it's just again the
Ah,
rendering. The resolution was a little grainy.
I see. Is it better now?
It is actually, yeah,
Great.
yeah.
Alright, so now I know what needs to be inlined, and now I need to actually inline it. So how do I do that? So if I have this little structure here, that's actually a tree of nodes, how do I swap this reference here with something else? Well, it turns out I will need to basically walk this tree and figure out when I have this reference, and if I do, then return a modified version of this tree that has this thing in mind. So let's do that. If count is 1, then I do the inlining. So for all the nodes in my rules, I will replace that node with a modified version of that, and I will modify it by inlining this a reference to this name by the corresponding name. And this is getting hard to follow, isn't it? So I need to have more I need to have better names, right?
How about yeah, okay. Well, for node and rules.
Okay, so I go through all the nodes in my rules and I replace I can name this better.
Like statements. No.
So yeah, this is the I'll I call it node again, but
Leaf.
replacement, right? So this is
okay.
the thing
That's cool. Yeah. Yeah.
replacing with, and this
Well, that's really
this
nice.
one
Yeah.
is replaced name. It's only replaced if count is 1, right? So replaced name is the name here. And then I go through all the nodes in my rules and do this inlining there. Great. What is this node? Oh yeah, I want to go through values. Right, and now I see that my little optional object has no attribute inlined. because I'm calling a method I didn't define yet. So
Oh,
the inline method
okay.
will take a name and a replacement and will return a new version of that node with the something replaced. So that means I will need to go through all my, like, these generic classes that have some kind of children, and define how they will be replaced, right? So if this is a container, I need to go through all of its items and call inline on each one of them, right? So I will do the same thing as I will take the self type, right? If it's a choice, I need to return a choice and so on. And I will return a new instance of the self type where items will be items dot replay inlined with these arguments again. Something like that. Does it make sense?
Yes. Yes. This is this is great.
Right. So this could be made more generic with some kind of modify container or do something like that. Right. So this operation could be a parameter, but I'm not doing that just yet. Now that you could say how to modify each child, and then do that generic modification with inlining. But since I only have one of the methods like this, well, I already also have simplify, which is. So if I was doing a simplify, then and then I would
simplified
have simplified here and simplified here, and
I see. Right.
So there's a little template that I could make generic, right? So I would define a transform like this.
Oh, okay. And then it would either be simplified or inline.
Do that. And the nice thing about this is now I can define this transform on each of my classes that I will now do inline for, and I wouldn't have to define inline and simplified each time. So that's something I will probably do when I have more methods like inline in the future, but right now I'll keep it like this. There's just one. So I need to do this for containers. I will also need to do it for decorator, which is a node with exactly one child, and that'll call it with self dot item dot inline blah blah blah. There. There. And I will need to do it for the gather, which has two children, a special case. So it has self separator and self item. And I will need to do this for leaf as well. Leaf doesn't have any children, so it just returns self. Right? items. And yeah, well, there's some rules. This should be node. Ah, right. I need to do rule name and rule node, maybe like that. So now everything is successful, but I didn't get any inlining done. And the inlining magic will happen in non-terminals. So I will specialize the inlined here. I'll probably take the self-type again. And so if I'm inlining the non-terminal, then if my value is the replace name, then I return the replacement instead. Right, that's all terminals replaced by this. Otherwise, I return self. That's probably better spelled as supercall.
Yeah.
That doesn't really matter in this case. And what happened? What happened here? It's aligned. See? It's now statement plus.
Wow. Yeah. Yeah.
Simple statements here got inlined in here. And I guess that whole thing got inlined into interactive. Nice. And here that thing got inlined into here. Right, so there's one more thing to do, and that's to remove the rules that I successfully inlined. So there should be a del what's the name? Now I should be careful here about not doing this delete. So I'm mutating here, so I should be sure I'm not using this name anywhere else, but like here. So I'm only going through each name once. So this item access happens after this delete, so that should be fine. And then I go through all the rules remaining here. So if there are any deleted, that'll pick them up. So everything should be fine here. And how will that look? You can already see in the diff that this is getting rid of all the craft that's now inlined. Isn't that neat?
It's really fascinating.
Okay.
One of my pet projects is I've been working on a little crawler for Google Docs and Sheets, and this sort of like walking the trees and changing things is really handy. Because Google Docs have like their own sort of special DOM.
Ah, I see.
And so, basically you have to, as far as I can tell, I've had to, write my own code to navigate it. And essentially I'm just looking for URLs inside docs and spreadsheets.
Lots of tree walking.
And they have their own, lots of tree walking. Oh my God. Yeah.
Right, so that's the first step here. So there's a bunch of code for inlining now. let's make sure we don't lose it. And this is a very long function now. And I guess before splitting it up into individual named function, I'll just add some comments in here. So next up.
Cool.
While I'm writing this up, there's one more thing. A rule that's only mentioned once should be inlined, except if it's explicitly given, right? So if I go in here to the input section and I would say file and statements in here, I'm saying that explicitly that I do want the statements rule included in here. Does that make sense?
It does.
So then I can, for example, mention that in the prose and people will know what I'm talking about. So let's add that bit of logic. So if name is in rules and name is not in... that's yeah, that's the naming sucks here. I'll fix that, but I now didn't get the inlining here. That's what I want. So let's change rule names to oh my god, what's the name here? What do I name the input to this function? A list of rules I explicitly want to have documented here.
Statements?
Excuse me?
No. Statements? No. Let's see. No, it's more general than that.
Naming's hard.
Naming is hard. Can you
request it?
Maybe bring up a request it. Okay. Oh, that's very nice.
Right, so now this should be
There's a funny technical name term for things that only happen once. They're called hapax legomenon. And for shits and giggles, I put in a little a link to the definition in the chat. Yeah. Hapax.
Hapax.
So it used to be a really obscure term when I was in college, but that was before text processing became a thing.
Oh. Okay.
So now it's very common in computational linguistics.
Huh. Quite common. Yeah, that makes sense. Oh, interesting.
Anyway, I figured you'd get a kick out of that.
So now I go back in here and remove the statements in here. Okay, so what's next?
Oh wow, I don't remember.
Well, next is actually to simplify the result.
Oh, okay.
Right. And what I will want to do is do this in a loop. Simplify inline, and then simplify an inline, and do that as many times as needed until the result stops changing. Because when I inline, of course, the number of references could go down. Right? But the main part will be simplifying stuff, right. Because, for example, this is now 1 or more, which is optional, which makes it either 0 or 1 or more occurrences, which is 0 or more occurrences. Right, so this should be statement star instead of statement plus in square brackets. So
right, because there's nothing else. Okay.
So let's do one iteration now. So this is simplification. And I do that for all the rules. Nope. Oh, we don't have the simplification yet. Do we? Yes, how do we simplify optional? Optional. Oh, if there's optional 1 or more, it should be 0 or more. Huh. Oh, I need to do that after inlining. Right. Okay, so now that's simplified.
Oh, wow. Okay.
And I wonder why this new line thing didn't get simplified. We'll look at that next. But you probably want to leave the simplifying out here. And do all of this in a loop. Right? So here we have, well, let's put this in Git first. And we had this this trick last time where we remember node before simplification, and then until simplification changes, stops changing that node, we simplify in a loop. So
Yeah.
let's do that not just with simplification, but with all of this, with inlining and simplifications.
Okay.
Right.
Yeah.
That is probably a big enough chunk to put in a function. Let's call this a rule set.
Mm-hmm.
Okay, and even it fits a dictionary, right? So
Would you want to call it a rule dict, or is that being too?
I think rule set is like a
too
term,
literal.
right?
I like rule set, but I just wonder if people might think that it's of type set.
Well, then let's say they're wrong. Right? It's a dict.
Okay.
This is good. This is what type annotations are good for.
Yeah, exactly.
Okay, and this will set of rules. I mean, just like this is set in the English meaning of the word.
Yeah,
it's not
a collection of rules. Yeah, exactly.
Yeah. Well, you know, collection.
Yeah, exactly. Well,
is
okay.
also a Python term that does not include a dict.
Yeah. A group of rules. How's that?
A bunch of rules, right?
A bunch of rules. That's beautiful. Exactly. That's English.
And I need to call that, right? So did that work? that shouldn't work. I guess it got stuck in an infinite loop.
Mm.
Which is possible, I mean. Why am I... Well, let's put generate all descendants at the bottom to make the diff easier. So simplification is gone. And did I leave rules somewhere? No. No. Failed refactoring.
I don't know what the I don't know if the recording, if the live stream has a higher resolution, but it is difficult to read the text of the console output.
Oh, no. Yeah, maybe I can make that bigger.
Oh, okay. Yeah.
Let's see. Right, so there's an infinite loop somewhere here. Like it's stuck in generate rule names.
Oh, it says
somewhere in here.
while. Yeah.
In this while.
If
While
rule name and rules
strat,
continue.
because I took out more than I wanted, I guess. Ooh, fun.
Wow. That's a lot of
That is a lot.
What is it reading again? Wow, rule names to add? Rule names to add. List rule names.
Rules. Top level rule names. What is going on here?
What is it getting as? Is it reading the whole direct, like, is it reading like a whole directory as input?
Recursing into expression and finding all the terms and factors. And it shouldn't recurse to expression because I have these top level rules here. And yeah, I didn't add stuff to rules, right? Now the simplification here adds stuff to rule set. Right. So right in here I had a simplification step that also adds stuff to my rules. Like this thing.
Oh, I see.
Yeah. And I probably want to call this rule set as well.
Rules. Requested rule names.
Right, and now this is its own function, so it's not getting all the arguments like the global stuff. So it's not getting requested rule names that it needs. And whoa! Del statement is now recursing into star expressions. Why is it doing that?
Star expressions. Del targets.
What? Well, I mean, the way to prevent that would be to put star expressions in the future top level rules. But I have no idea why it started doing that now. Like, what does the grammar say for
Del statement.
Oh, del targets. How did it get star expression? Well, it's probably because before I was simplifying before inlining, and now I'm inlining first and simplifying later.
Oh, is that what you want to do though? Inline first. Yeah, I guess that is what you want to do.
Yes, I definitely always want to end up with a simplified result.
Yeah.
If I did it the other way around, we wouldn't get the well, if we want to loop until things stop changing, you can do it that way as well. Right, and that got rid of the the weird change in behavior, which I probably don't want to. Oh, that didn't. Huh. So I wanted this to be a refactoring, but yeah, something changed in the process. Let's go through the diff. So, rename the rules to rule set. The simplification is now gone from here. So I'm generating all descendants from the non-simplified variation. It should be fine. I mean, the non-terminals, the set of non-terminals will be the same. Then I'm simplifying the rule set, and this will be the same as below. And to simplify a rule set, this is using the name. We simplify, we inline the found rules, and this diff is weird, but that should be the only weird thing about it. Let's check all the variables we're using. Notice from here, descendants from there, requested rule names were, that's fine. Last node we're setting, reference counts we're setting ourselves. Yeah, this looks okay. The result is now fine. So let's go with this. So I want to simplify the rule set until it stops changing.
Yes.
But
yes.
Now I'm using a dict and mutating it. Right? All the nodes are immutable, all the nodes are frozen, so I need to make a new version whenever I change something. But the rule set itself is mutable, and I'm actually mutating it. So I will want to construct a new one, I guess. So let's call this old rule set. And this generates the new rule set here. I guess I want to put the simplification first again. The old rule set in here.
Oh, I see. Okay, right, because it's frozen.
Yeah, well, it's a dict, so it can be frozen. So I need to be careful not to mutate the old one.
Yeah.
But right now I should be only mutating the new one. Right? And then I do this loop here. It's probably better to have this loop here. So do simplification in a loop, then do the inlining once, and then we do simplification again and again and again. So so that should be the same trick as here, except now with simplifying the whole rule set. What changed? I'm getting this invalid del statement. Oh, I do need to simplify at least once.
Before you inline? Oh, okay.
To get no. I do need to simplify before generating all the descendants here, because I don't want to find this invalid del statement. That's what brought in the star expression things. So I do need to have this simplification thingy in here. And that means it's now in my program twice, so I need to pull it out into a new function.
Right, to keep things dry.
It's quite a... It's not a straightforward algorithm, so let's give it a name. So I do want this for one node only. Maybe I want to call this method like simplify, like do one step of simplification. Return that. Okay, so still getting that invalid thing. Where am I removing invalid stuff? Yeah, that's in simplification. I think I broke something.
Well, we had a del statement. We had a del statement in one of the simplifies, didn't we? Del. It was like at the end of a return. It would return something and then it would delete it.
I see now. I need to say node equals simplify node. Then add it. Because then I'm generating all the descendants from this node. And if I'm simplifying the only thing I stash in here, it doesn't get into this part. Ah, dear. Okay, now everything is in order. Let's put back in the comment. Okay, so that should be it for simplification and inlining. Hopefully it's readable now. Probably want to go through it and put in some more comments and better names, but the thing I want to focus on now will be these new lines here.
Yeah,
those should be all taken out. Right, so an interactive input can be either a compound statement or multiple simple statements or nothing followed by a new line, or it can be just an end marker. How come that is not being simplified? So I have this choice And that has... right. So if you remember the simplification we had for choices, we're simplifying all the alternatives of the choice, converting them all to lists. So if there's so if there's a sequence, we unwrap the sequence into a list. If there's just one thing, we wrap it in a list. And if there is nothing, we ignore that nothing and make the whole container, whole choice optional. Right?
Yes, yes.
And then we have a special case for the definition of gather.
Okay.
No, have a special case for... That should really have a comment. So if we have either something and... either something or...
or some choices.
Gather and then something optional, then we ignore this this X because it's... This should have an if here. I'm doing a review for myself here. Didn't change any of our our stuff, but right. So this says if we have this complicated option in the, or rather, if one of the choices is this complicated thing, which is stuff separated by something and then optional something, and the other choice is just that stuff, then we ignore this this branch and just have that. So that's a special case. We'll probably have more special cases like that. But now let's go on. Then we define this wrap function, which we use a bunch of times afterwards, and that case takes care of this is optional, right? If we said that our new container is optional, then we need to wrap it in optional, right?
Yes.
What's next? If we're left with only one alternative, then we return the first alternative. We need to put it in a sequence because it's a list. If there are no alternatives, we return an empty node. That will hopefully get simplified further later. And then we get the first alternative and check if all of the other alternatives share the first item in it, and in that case we put that first item out of the choice, and we do the same thing with the last item here. And if neither
do we want to make it a... if we make it a set, would we get rid of those redundant new line or redundant
No. So
the duplicate
what happens if I take this away? So this is for this eval. So this choice here.
Oh.
Right?
Okay.
So it has expression this choice here has expression at the first position everywhere. Right?
Yeah.
So we simplify that into expression, and then took expression out of everything here, right? And then because one of the arms was empty, then it further simplifies into this being optional. And what else? We probably then have a special case somewhere saying that, no, this is that special case we had before. If we have is it that special case we had before? I don't know. Basically one of these is this whole thing is optional. So it's the same as if this was optional. Well, I'm getting lost in the steps right now. It's probably not important. Anyway, the important thing is if we have a choice that starts always with the same thing, we take the same thing out.
Right.
Is that
That's a good way to
clear at least? Okay. Now the problem here is now we have a choice where most of the items end with the same thing, this new line, but not all of them. And we would still probably like to simplify this into a compound statement or simple statements or nothing, followed by that new line, right?
Right. Yeah. So there's just one new line.
Yeah, just one new line. So we cannot use this logic where we compare everything with the first alt. What logic should we use here? I guess it'll be very similar to the thing we had with the simplify subsequence here.
Right, because we did the tails.
Like, look at each of the tails and
Mm-hmm.
and see what we can do. So yeah, so this is getting a bit complicated. What happens if I remove this? Break something. Right, this should probably also
When, when we're looking at the alternatives, is this a case where we would want to start at the end and work backwards?
now this
Does that make sense?
So looking at this this particular special case,
Mm-hmm.
if we have multiple alternatives in any order, we probably want to detect this thing and then look if any of the other alternatives are in the, of this form and remove them. When going here, we probably want to look at each of the alternatives in turn and see if any of the other alternatives end with the same thing. And if they do, then take that same thing out. Does that make sense?
It does.
It makes sense in theory, but
Yeah, exactly.
writing
It
that
makes
in
sense
code
to
will
me,
be
but
a bit fiddly.
yeah.
How to do this? So we probably want to do this similar thing like this simplify subsequence.
Mm-hmm.
Except this little helper method will get one of the choices, one of the alternatives, and also a list of all the others, and it will be able to modify that list of all the others.
So it's simplifying alternatives.
Yeah, simplify. Simplify alternatives. Right, so so yeah, we have a list of lists, and we'll want to how does this work? Yeah, it uses a while because so in the sequence cases we use a while with an index, because that index because we're changing the sequence, we're basically iterating over, so the index can increase by more than one, or we might oh no, this is doing new items. It's doing stuff in turn. I don't know, is me thinking on stream interesting? Like,
It is. It's very helpful. Yes. No, it's wonderful. I'm actually very grateful. I mean, if it's distracting for you, if it's harder for you, then
well, it is harder for me,
don't
but
do it. But
I'm also happy to make a fool of myself.
this is good.
Don't know how to proceed here. So I want to take each of the alternatives in turn and see how it affects all of the other ones. And in case it does affect all of the other ones, it can change the other ones in any way, or it can take some of the other ones out. Right.
Well, we can we count on the list of alternatives going from like more complex?
No.
We have a list of lists, right? Isn't it always the case that the last item in the list is the most unique?
No.
And or the smallest, shall we say?
No.
And then no, it doesn't. Okay, it doesn't work that way.
No, it doesn't work that way. The order. So it's a peg grammar, so the order actually matters.
Right.
I said that in the simplification. I don't care too much about preserving the order, but
Mm-hmm.
if I can, I would like to preserve it.
Okay. So if we, I think what I was trying to say is that if we look at this list here and that example you were pointing at, the last item in the list is unique.
Mm-hmm.
And then the next to last, the -1, is duplicated with the -2.
Yes.
And so I wonder if we say, okay, we look at the end, and then we compare the last item, we compare the -1 to the -2, and if it's different, then we keep them both. And then if the -2 is the same as the -3, then we can drop one of them.
Right.
Does that make sense? And then we read the next item.
So, I guess
and
it
we'll,
would
we'll see
work
that.
to do this pairwise. Right? If we
Yeah.
do this, we consider this pair here and simplify that one to compound statement or simple statement new line. And then the next round of the simplification looks at this pair.
Okay. Yeah.
And generates something like this.
Yeah.
And then we should, this nothing gets simplified away, or we could have a generic simplification step where if one of the alternatives is itself a choice, then we can remove that level of nesting. And then of course, if there's one of the alternatives is nothing, then the entire thing should be optional. Yeah, that makes sense. So going pairwise is probably a good choice because it better preserves the order, right? If I took this thing and simplified it with like the last one, it might simplify things more, but it'll also mess with the order. So let's do it pairwise, or well, I guess not only pairwise, but
group in chunks, chunkwise.
Yeah, chunkwise, like we did with the sequence, right?
Mm-hmm.
So how well was that? Let me ask. So we're creating a new list here. Each of the items is consulted in terms, basically. Sorry, creating a new list here. Indexes first set at once, and then while there are some items to process, we simplify this. Simplify subsequence, which can take any part of at the start of the subsequence, and do some asserts and update the index by the number of processed items. Well, let's just copy this wholesale, then we'll simplify it. So this will be new alternatives instead of new items.
Mm-hmm. Yeah.
And this works. The replacements should be lists of nodes. So I guess we can't really have this assert. But otherwise it should work. So simplify subsequence. Will in the base case return the first part of the tail, and one. And it'll be a list with the first part of the tail, since there can be more of them. Okay, that's unchanged. Perfect. Now let's put this in here. So let's match the first two items of the tail. Right? So if there's just one, this would be a list of one thing, so it won't match anything. In all other cases, we will have two items here. And did I take too much from up here? Probably. Something's missing. Return results, and we got two out. Right. That works. Now in case we have anything followed by a common had one and had two, x1 and x2. This is too much of math, math-like notation. But I'll figure out better names after I write it.
Okay. Right, and I shouldn't do sequence here, it's a list of lists. Huh, no. I should bring back the assert there. Let's see. Alternatives extend shows, so this should be a list of two things, and this common last node should be a node.
So this replacement should be a list. All things in it should also be lists. But all things inside that should actually be nodes. So should be a list of lists of nodes, right? And the same goes for alternatives here. And alternatives afterwards. But well, guess this is all right. So what am I looking at? Simplify item here called from
line 144.
Excuse me?
Line 144?
On line 144?
Well, that's what the error says. It's
yeah,
blowing
this
up on.
is just simplify item.
Oh.
No, this return. This is somehow returning a bad data type. Should be a list of nodes. Is it time for Snooper?
Yeah, really. Display all the values.
What's the name?
Yeah. Snoop.
PySnooper?
Or maybe it is Snooper. They have a.
Is that the
PySnooper is the original one. That was the original one, and then I think maybe Snoop is the
Snoop.
Is the fancy
right. Okay.
Whatever, next generation.
Let's go for that. I will probably need to allow PyPI. Do I have a virtual environment? No.
Oh, you're a bad boy.
Create a virtual environment.
Oh, that's clever. Naming it Dunderband. I've never thought about that. Does that have special powers, or is it just for convenience? Okay.
I'm sad about because it should, but nobody uses it. Okay, so I will now need this for Python for my docs generator. Right, and let's see if I can use Snoop correctly here. So that is that
At Snoop.
at Snoop. Okay.
And you have to import it at some point.
Snoop. Right, let's see the magic. Yeah, this is just too colorful.
Ooh.
Dear, 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 dear. Oh, sorry. Maybe with Snoop in a smaller section of the code. I hope this works. Yeah. Okay. So.
Oh wow, I didn't know you could do that. That's cool.
Yeah, I read through the README.
Yeah.
So here we're called with. I hate this.
Huh.
Okay, so we're called with. So H1 is simple statement and common last mode is new line. H2 is some kind of gather thing and common last node is new line, and I return. Oh, it doesn't say what I returned.
2.
Okay. So result is choice. I see it now. H1 and H2 are lists, but I'm creating a choice directly, so I need to convert them to sequences.
Oh, I see.
Now this is not great. Juggling lists and sequences. Oh, nice. Okay, so what happened? Wow. You see that?
That's actually kind of cool.
Whoa.
That is kind of cool. Yeah.
That is extremely cool. And unfortunately, I will need to go soon, but
Well, do a commit.
yeah, I will want to do the same thing with the common first node, and then get rid of this bunch of code. But yeah, I'll do a commit and return to this later. I'll also remove the Snoop before committing.
Oh, do you want to do the with? Remove the with Snoop?
Yeah, I already
piece?
removed that.
Okay.
And I'll make it a temporary commit. Maybe not.
Could you add me as a co-author in case I search for things later?
I could, but I'll probably squash this later.
Oh, okay. Well, don't worry about it then.
There it is.
I have the string in the chat.
Remind me to do this for the final commit, final
Okay, sure,
request.
sure.
Start.
Yeah, no problem.
Start simplifying.
Here's alternatives. In choice.
Yeah,
Cool.
definitely remind me afterwards. I should really add you. Because you're always asking questions and.
Yeah, I'm making myself.
Oh, that's exactly. You know. That's exactly why I'm doing this stream, to have a second pair of eyes.
Sure, sure.
All right. I'll put that on the GitHub branch, and see you next week. Thanks for joining.
Yeah, man. Take care.